All right, we've just finished the culvert training. So now we're going to go back up and look at the storm drain shapefile development. So there's going to be two videos. The first video will kind of just outline the process of creating and quickly reviewing individual storm drains. And then the second video at the bottom of this, down here at the bottom, will be a little bit more detail on that. So we may not have time to go over the second video, or we might not do that in class, but you might find that you finish early and you can watch that second video. So let's start with importing the three shapefiles, inlets, conduits, and outfalls, into the system. And they are located in the storm drain folder. And we will set up the map, clean up the map, add the three shapefiles. And by the way, if you can't see these or they're not looking very clear, that Google Map doesn't render these very well. So just open them in a new tab and you'll see that they look really nice. Open the attribute table. We're going to take a look at some of the attributes. We're going to add a few fields to each one of those tables. And then we're going to stop the video, or just, yeah, then we're going to stop the video. Then the second video will be a little bit more on how to set up these shapefiles, like if you're starting from scratch or something. You know, typically when you start these, you start from the data set that comes from the city. All right, so let's do this. Let's get in here to our map space and let's clean it up a little bit. So we don't need the image. We don't really need to see the grid. So I'll turn off the image down here and I'll turn off the schema layers because I don't need to see the grid or the channel or anything like that for now. Everything else is fine. We can just leave everything else on. We'll turn things on as we need it. And then these three we turned off in the last one, so they should still be off. And then click the boundary condition lines to make it blue. And then over here in the project folder, so we'll go to the coastal training, project data, storm drain, and then just grab these three shapefiles. And again, remember, if you can't see that .shp because you can't see your extensions, that's no problem. Just come over here and look for the SHP. And you can just drag all three of them straight onto the map. And then we're pretty much done with this for now. So we'll just move that out of the way. And these are inlets, junctions, and outfalls. Sorry, inlets and junctions, outfalls, and of course, conduits. So the conduits are the storm drain pipes, and the outfalls connect the water back to Flow 2D grid at the outfall, and the inlets capture the rainfall. They're the catch basins. They capture the rainfall and allow that water to go into the storm drain system. So your typical storm drain system needs invert elevations, pipe diameters and dimensions, offsets, slopes, things like that is what the kind of data you need to get the water into this system and allow it to flow down to its outfall and get back out onto the grid. Okay, so let's start with, let's see, I don't want to miss anything from this. Okay, so we go attribute table. Let's start with the conduits, since I think it's the one that's in the instruction guide. And you see it has a name. And then this is the inlet node that's connected to, and the outlet node. This data needs to exist, but it doesn't. It can just be placeholder data. So you don't actually need any text, any data in here, because that will be filled automatically by Flow2D. So you could just put in here like some kind of placeholder script, string. So this is a string, this is a string, this is a string, this is a string. These ones have to be all caps, and they have to kind of match what is required by the swim GUI. So if you can open up the swim GUI and see some of these names for the pipe shapes, you'll see the exact spelling on those. Maximum depth is well, this is a vertical ellipse, so this would be the vertical depth, and then geometry 2 would be the horizontal width. And if that was circular, geometry 2 would be 0, and the maximum depth would be diameter. If this was rectangular, geometry 2 would be width, and this would be height. Number of barrels, 1, 2, 1. I think we have 1 and 2 barrels in this project. See how I can sort the data by clicking on the field? Pipe length. With Flow2D projects, the minimum pipe length is 20. The minimum pipe length must match the grid element size. So we have any pipe length that is lower than the grid element size, reset it to equal the grid element size. It's a very simple thing to do. You come here, you click the editor pencil, and you can do this, change this to pipe length, and put in our case it's 20 and update selected. That's how simple that is. And Manning's goes by, is it corrugated, is it concrete, etc. Does your pipe have an offset? So typically when these pipes come into a manhole, the upstream side will be higher than the manhole, the bottom of the manhole. The downstream side going out of the manhole will also be higher than the bottom of the manhole. There'll be an offset because the bottom of the manhole has that clean out area down there. But not only that, but there might be multiple pipes coming in different different offsets into that manhole. And this is how you set those up. This is just a depth or a distance between the invert of the structure to the invert of the pipe. You don't need pipe material, but it does help you define the Mannings. And that's about it. Now, what's missing? The non-required data is missing. So let's go back here and let's see what we need for conduits. So the non-required ones are right here. Initial flow, maximum flow. I don't have any loss coefficients in these. That's not really the way you want. You would want to probably put in some loss coefficients, but just for simple projects, we can leave them off. And does it have a flap case? So let's add a couple of these just to that shapefile. So I'm going to go here and I'm going to click edit. And I don't need to have anything selected, so I could click this one here. And then I want a new field. So I'm going to click a new field, and let's name this new field Flapgate. And it is an integer. And it is an integer of length 1. Okay, now if I come over here to Flapgate, it's either 0 or null. So let's start by setting them all to 0. And we'll update all. And then if we had one with a Flapgate on it, we could come down here and we could just put the number 1. And you can see that it would give you that structure now has a Flapgate. So that's how you do Flapgates. Very simple. And let's try one more that's not an integer. Let's try an average loss coefficient. So let's just go here with the new field, and we'll call it AVG loss. This is a decimal number. And I believe these loss coefficients are, well, I'm not sure what their restrictions are, but let's just say that this can have a precision of 3 and a length of, let's say 5. And I'll click OK, and I'll show you what a precision of 3 and a length of 5 means. First of all, we'll give them all a 0 just for now, so update all. Now let's say if one of the, let's put that one back to 0. If one of these had a loss of like 0.5, and I put that in here, you could also do, you would see that that would be how you put your loss in here. That would be your loss coefficient. But the way that the precision and length works is that if I do 999, see I had it to length 5 with precision 3, then that means the precision is 3 decimal places, and the total length of the number is the precision plus, or the length of the number is the total length of the number minus the precision. So it was 5. So we have 3 numbers here. So that's how the length and precision works. I'm just going to set those both back to 0, just so, and then I'll click save. And that is how you would add a missing field to your system. Now, what if we had, let's say we had a inlet and junction and we wanted to add a clogging factor to it because we know it clogs every time it floods, okay? So let's add a clogging factor to the inlets. So we have open the attribute table and we hit the edit pencil and we add the two fields, the clogging, let's say clogging factor, and that is a decimal number, and the precision, it can't go over 1, so the precision is 3, and the length is 3, and the precision is 3, and I'll click OK. Let's get over there and see it. And then the time, wait, what was the other one called? Let me grab the variable again. The time was called time for clogging, so let's just call that clog time. So the next one we hit again to add it, and this is clog time. And for clog time, we have a whole number. Sorry, no, this can be a decimal number, and it's time, so it's never going to go. Well, let's see, time. You know, your typical model can run up to hundreds of hours, so we can just say, let's give it a precision of 7, and sorry, a length of 7 and a precision of 2 or 3, probably 2 for time, and you click OK. Now let's take a look at these variables. Now you do not need zeros in these because if they're null, they will not be written to the file. So if they have a null, they'll just be ignored. If they have a time, so the clog factor is 0. Let's say that the clog factor reduces by 50% at about 8 hours into the simulation. Okay, so at hour 8, this inlet will reduce, inlet I-262 will reduce its flow by 50% at our time. So that's how a clogging factor works. Just going to delete those out of there because I didn't have any clogging factors set up in the original. I just wanted to show you how that works. And then the final one is outfalls. And one of the important things that we're missing in outfalls that might be important for coastal flooding would be a water depth. All right, so if I hit edit here and I add a new field, we can call this water depth. So that would be the depth, the initial depth on that outfall. And let's say that would be a decimal number, and the precision could be 7, and the length could be 7, and the precision could be 3. And now we can add a depth above the invert of this, that is that this structure is full of water up to that depth. And that, or you can add like a time series of depth on here. There's other things that you can do to these. Let me check the 2 more fields that I forgot. Okay, you can have a tide curve or a time and stage series on this. It's either time, stage, or maybe time discharge. And that's how you add missing data. And that's how these work. So I'm going to stop this video and then we'll go into the next video, which is a little bit more about that data and how you put those shapefiles together. So go ahead and stop now.